Hello everyone. Today we're going to be applying reverse engineering in order to break a software or break the software's protection. So before we delve into the scenario, let's first discuss about what reverse engineering is. So reverse engineering, which is also known as backwards engineering or back engineering, is the process by which an artificial object is disconstructed to reveal its design, architecture, code, or to extract knowledge from the object. Reverse engineering is applicable in different fields from computer engineering, mechanical engineering to software engineering, and even in chemical engineering. So often reverse engineering is used to break software protections, but it can also be used for offensive action or for good intentions, which can help to identify the malicious codes and backdoors inside the software that you have created or that you are supposed to be testing on. So there are many ways of performing reverse engineering. There are many techniques and tools. So primarily there are two approaches. First is the offline code analysis, and second is the live code analysis. So in offline code analysis, this approach takes binary executables and disassembling or decompiling it so the inner structure of the file is revealed. So usually the offline code will enable us to safely unpack or the malware samples and allow the inner working of program to work with even without executing it. So that's offline code analysis. But live code analysis is completely different because here you run the binary executable in a debugger or inside an executable environment while doing this live code analysis. So in this scenario, we will be performing a live code analysis on a executable file. So before that, we also have some terms and conditions terms here. That's cracking, patching, and key jaining. So cracking often means to breaking into a software, breaking a software or breaking into a software in such a way that it behaves in an unintended way. So the code or the software that is supposed to be run in a certain way will not work in the same way that it is intended. So patching is another term that is used, which is a process of where you modify the code in binary executables to alter its intended behavior. So it's usually used by crackers. While cracking, they use executables, softwares, and games, and so on. So key jaining is basically the process where you reverse algorithm that is used to generate the serial key, and then you produce those keys required for the executables. So in this workshop, we'll be provided with one executable file. This is this file. So before that, let's see at the tools that are required in order to perform our little scenario. So first, let's before that, you have to have wine environment installed in your Ubuntu machine. So if you don't know what wine is basically an emulator for Linux or Ubuntu distribution that through which you can run Microsoft or Windows software on Linux or Ubuntu. So first you can check it by typing wine -version. So if it is installed in a computer, it will say it is installed, but it's not installed. So you can basically install it with this command: sudo apt install wine. Sudo apt install wine. So it might take a little while here. Let's wait a second. As you can see, it looks like it installed. Let's see if it's installed. Yes, as you can see, it has already been installed. So now we need to download another tool that's very important for this scenario is OLED-BG. This is a decompiler that is used to decompile this Microsoft executables, so you can perform some reverse engineering action on them. So let's go to this link and download the zip file for this, and let's download it. So basically just save it, and if you go back to your downloads, as you can see, there's already the OLED-BG. So basically you can just simply extract it here, and you'll have your OLED-GB file in here along with the DLL. So there's an help file as well if you want to know the workings of this tool. So let's go back. So after we've installed that, now we need to open the as you know that OLEDBG is a Windows application. This is a Windows executable.exe, so that's why we installed wide environment that allows us to open the Windows application inside the Unix environment, right? So let's open this file using, let's go to that directory first. As you can see, we're inside the file. So from here, let's open this file using wine. It might take some time, so as you can see, it's here. So now first we have to extract our file, or the keygen file that has been provided to us. Sorry, I pressed the wrong button here. Okay, let's go back to the top. So in this scenario, we have been provided a scenario where we are working as a product quality assurance engineer for a software company that usually sells software products which are based upon subscription and product key model. So recently we found that the product key module for this application can be bypassed with a simple assembly code manipulation, but we don't know how to do it, and we don't know the source code as well. So we are going to be performing some forensics in here, or some reverse engineering, in order to find what's wrong within this code or how we can patch it, right? So we have been provided an executable file. That's the software that we've been talking earlier, so we can extract it, and the password is given ctf.tf. So let's first do that. This one, let's execute it, ctf.tf. So as you can see, so let's extract both of these. Extract it. Let's extract it here in downloads, right? Now we have the files here, right? So this is the key generating software, or the software that has been provided to us for testing. So now let's open that in our OLEDBG. So first let's open the software, key4.exe, right? key4.exe. So it might take some time in order to load the file, so let's be patient here. It's taking longer than usual. As you have to load the whole executable file or a software file, it might take some time because there are lots of components that go inside the software. So while this loads, let's first try to open this software just as simply as it is supposed to be. So what's the software? So okay, what's happened here? Oh, it's an executable control. Okay, as you can see, it has been loaded into our OLEDBG. So let's maximize it. As you can see, this is the OLEDBG window. So basically, as we already know, that OLEDBG is a debugger for disassembling and debugging Microsoft binary executables. As you can see, there are various sections or columns, as you can see inside this Windows. So basically here you can see some instructions or the bytecodes in this side, and then you have some result API information in the here, and here you can see some CPU registers, and here there's a stack, and there's a memory that is viewed as a data. So that's basically what's going on in this OLEDBG system. So first, before that, let's run the file as it is supposed to be. So we can run it from here. It's a run button, and let's, okay, where did it go? As you can see, it is a keygen. So let's first type anything and see what happens. Let's just say here, let's just type 1234, and let's see. As you can see, the new message box will pop up, which will say that you have entered a wrong serial key. Please try again. So we can't enter the application unless we have installed the, or we have entered the proper key or credentials. If you see about, there's some information about the software research. So now let's get inside, applying the, okay, I think something might be in problem here. Okay, that's my bad. We have to load it again. Just wait a second. So as we already know that our message box had pop up there when we enter the wrong name and key. This means that the message box can be treated as a reference point. So from where we can, because basically if there's a message box, there must be some function that is calling upon in order to show that message box. So we can check for that. Probably the function might be checking the our input against the actual key that is written inside the program. So there are various options that we can go about to perform this patching or reverse engineering. So inside this OLEDBG, we have an option to view the executable modules. So as you can see here, when we view the executable modules inside this binary file, as it is a Windows binary file, there are lots of almost all the dependencies are to the Windows DLLs or the System32 that are inside the C drive. So all the dependencies are to the same DLLs. There's no other dependencies inside this file, so it makes our work a lot easier, because if there were other dependencies to other libraries or modules, we would have to modify those libraries as well, and we would have to know the knowledge about those libraries or those modules. So for now, as it is only on the Windows DLLs, so it makes our job a lot easier. So as we know, this is the main file, the key file, the exe file. So what we will do is, now we will look at the APIs, right? So we'll examine the API. So in order to examine the API, we will show names in here. So it will look at all the functions of the APIs that have been called by other modules. So as you can see, there's lots of modules are inside here. So we are interested inside the message box. So why are we inside in this particular address or this section is because, as we already used the program before, when we entered the wrong password or credentials, we found a new message box that popped up saying that you have entered the wrong key. So basically, message box, if you have a basic knowledge of any programming language where you develop a GUI, you would have known that message box is simply a GUI function that pops up a message box inside a GUI. So we know that this is important to us. So what we're going to do is, we're going to find reference. So we'll find what is inside this message box, or how it is being referenced. So now you can see here various call commands in here. So the first call command would be maybe this might be about the info or the about message box that had popped up when we pressed the about. This is when you probably enter like a blank input inside the boxes. So it is please fill in a char to continue, right? So this would be where you are ranked as this is when you have successfully entered the credentials. This is when we previously did this. When we enter the wrong credential, it showed the message that says it is a wrong serial and try again. So we are going to follow this in the disassembler. So basically it disassembles the assembly code. So as we can see here, this is the message box that popped up when we okay, this is the message box that popped up when we entered the wrong code. So now, the main priority is to bypass the code and to get this to this message, or to the rank as level 3 at keygening. So this is our main goal. So we will be ignoring this one. So we will be focusing on this message box. So if you have a basic knowledge of a assembly code or programming language, you would know that this CMP EAX or ESI is basically, it is like a loop or a condition, like a if-else loop that we use in Java or Python. So this is comparing some things, and if this condition is true, it is giving us this message box which says that we are successfully at getting to level 3 at key chaining, and if we have entered the wrong credential, it is showing this one which is saying you have entered a wrong serial. So now that we know that this is the main condition, and as we can see, there's some function being called in here. As you can see by this line, that a function is being followed in here. So basically what we can do is, now at this point, this function is checking against the key, and then if it's right with the input that we have provided, it is calling on this JNE sort function. If it's wrong, it is going on this in the other one, GMP sort function, right? So what we're going to do is, this is the main validating function that can be bypassed. So what we're going to do is, we're going to basically edit this, or we can just simply double click it, and what we're going to do is, we're going to make it non-operational. So what is just this, if we put this function as non-operational, the loop will not validate the input. So basically anything after that line will be non-operational. So we are going to symbol it and make it non-operational, or NOP. So as we can see that now the function there's no function in here. So basically, if we enter the wrong credentials or the right credentials, we will have bypassed the mechanism, and we will have been inside the correct, or as a level 3 rank in key chaining. Okay, now that we have made the function non-operational, so there will be no validating inside this program. So let's try to run the bypassed program. So simply just run the program. Let's try anything, bypass, right? Try any credentials as you want. So as you can see, we have bypassed the validation mechanism. So we have been successful to reverse engineer the code, or pass the code at a binary executable level. So what we are doing here is, this is simply just editing or bypassing the software inside the OLEDB environment. So now we have to make the software, make a new patched version of the software, or a new executable that can run from anywhere. So we don't have to follow this process all over again, right? So what we're going to do is, we're simply going to cancel that. So what we're going to do is, we're going to make a new executable. So we're going to edit, we're going to copy this code to executable, and we're going to select all this code, and we're going to save it into a new executable file, maybe like key4, give it a new name like key4patch.exe. We're going to save it as like that, right? So let's go to a new terminal. So let's go to terminals. As you can see here, the key4patch.exe is already here, so the patched version is here. So we're going to open it independently. As you can see, we've opened it. So let's try here, patch anything, right? Okay, as you can see, we have successfully made a patched the software, or a new patched executable. So this was basically our whole reverse engineering scenario for today, where we simply found the code that can be bypassed, and then patch the program completely, so that we don't have to do any validation. So now it says that how can we patch? So what other ways could be there to patch this such application? The same way that we did in our lab scenario, there could be some other way, there could be some other tools, right? So if other than the OLEDBG, we could use Dupe, which is a freeware patch generator that can be used to develop a patch executable for Microsoft Windows systems. So it also supports various raw offset chains, virtual address chains, text patchers, and everything. So there are various ways to patch depending on the dependencies that is had, or the binary executables that is had. So we can use various tools and techniques in order to patch the application. So that's enough for today. Thank you.